As you guys can see, today's learning target is I can write an exponential equation from a graph. So what I'm going to do right now is I'm going to do a couple of the problems from 66. What I would suggest that you do when I'm finished with those couple problems, that you go ahead and do the other two problems. I'll then go ahead and bring the video back up and it will have the answers for the other two problems on here. And then we'll work through problem 67 in a similar fashion. I'll go ahead and put a couple different pieces of video together. You are going to want to stop your video and see if you can do these problems on your own. Okay, first and foremost, what we need to remember is that we are going to be dealing with this equation y equals a times b to the x. Very, very important for us to remember that a is our y-intercept and b is the multiplier. Okay, so as you look at problem A, some of you are like, oh, cool, I see it's got a slope triangle of 2. We don't want to use slope triangles. We are going to use that piece of information that this is over 1 and up 2, so that we know that we're really dealing with the point 0, 5, and then we're dealing with the point 1, 7. That's going to be really important for us. In order to find our multiplier, we are going to take the new value, which is 7, and divide it by the old value, which is 5. So our multiplier is actually 7/5 or 1.4 if we want to do that. And that's because we're moving over 1 point. If I multiply 5 times 7 over 5, I get to 7. So as you can also see, we see that our y-intercept is 0, 5. So my equation in the form of y times b to the x becomes y equals 5 from my y-intercept. My b I got by taking the new value and dividing it by the old value. So that was 7 over 5 to the x power. So that's how I would be looking at problem A. I'm going to go ahead and also do problem D. So I do think you should take a moment and try problem B and C at this time if you can, or go ahead and wait. Let me do problem D, and then you can go back and do B and C when you're finished with that. So this time my 2 points are actually marked. So I'm going to actually just set up a quick table here. If my x was 0, my y was 7. And if my x was 3, my y was 56. And so what that's going to help me do is that's going to help me figure out that multiplier. And so what basically I have to think about, what am I going to multiply 7 by to get 56? Well, 7 times 8 is 56. But notice that I actually have to use b 3 times. This is kind of like when you're figuring out the slope. If you have the next number, it's really easy because you are just going to take how you go from one y to the next. But in this case, we actually used b times b times b to get to this 8. So one of those b's is really just 2, because what we're thinking about is b cubed equals 8. So b has to equal 2. And if you're not positive about that, really what we're doing is we are taking the cube root of 8, which turns out to be 2. So it turns out that b is 2. My a is 7. So my equation is y equals 7 times 2 to the x power. Again, this 2 really comes from the fact that I took 56 and I divided it by 7 and got 8. I took my new value over my old value and got 8. The reason that 8 is not my multiplier is because you notice up here the x values, it actually went 3 spaces. We went over 1, over 2, then over to 3. So I realized that b to the 3rd power has to be 8. So b equals 2. The reason this problem's different is because we weren't given consecutive points. There was a jump between the 2 points that we were given. Why don't you guys try B and C next? So now you can see that I have B and C finished. One thing that you really need to be aware of on B is it is exponential decay. So our multiplier should be between 0 and 1. I took my new value divided by my old value and got 1/3. 40 was my y-intercept, so it's y equals 40 times 1/3 to the x power. On question C, it is a horizontal line. That horizontal line is actually going to mean that our multiplier has to be 1. And so the y-intercept is 18. So I get y equals 18 times 1 to the x power. Next, I'm going to move on to problem 67. Problem 67 I have here on 2 different sheets of paper, and these problems were just copied out of your book. So if you have your book open or your ebook open, you can just follow along with that if you want. So this says Errol and Sandy are working at writing an exponential equation in y equals ab to the x form using the graph. So they have this graph and they need to write the equation. While trying to write the equation, Errol states, I think A must be 10 because the y-intercept is at 0, 10. Do you agree and justify your answer? Hopefully you guys do understand that A is 10 because that is the y-intercept, okay? B says, but we still don't know B, Errol noticed. His teammate Sandy said, I have an idea. I think that 32 10,000ths equals 10 times b to the 5th. How did she get this equation, and is it valid? So if I'm looking at this, what we're noticing, hopefully what you learned from the last problem, is that we do have 2 points that we could be putting in a table to help us solve this problem. The first point is 0, 10, and the second point we know is 5 and 32 10,000ths. So we could say that we were going to take 32 10,000ths and divide it by 10. And that answer is going to be, equivalent to doing B 5 times. So if you look at how I did part D of the last problem, we really end up with something that looks like this. And so if I multiply both sides of my equation, I get 10 times b to the 5th equals 32 10,000ths, which is what Sandy believes that we can do. So the question that most of you probably have is, so how the heck do I solve that? Well, actually, what you look at, what you will notice is that we need to do the reverse of what I just did. I'm going to go So ahead. If I divide both sides by 10, I get b to the 5th. Instead of 32 thousandths, I get 3200 thousandths. So now in my calculator, I am going to take the 5th root of 3200 thousandths. This is why in the toolkit today that I did earlier today, I was telling you the importance of this. So I'm going to have 0.00032. And when I take that, it turns out that B equals 2/10. I really strongly suggest that you do this on your calculator right now. Don't just take my word for it and figure out how to make sure to get this into your calculator correctly. Again, with this calculator, I had to get the 5th root by hitting the math button and then 5. Then I have to put a 5 up there, and then inside my square root sign or inside the radical, I'm going to put 3 zeros and then a 32, and I get 2/10. Okay, so that brings us to the question. It says now use the values a and b to write the equation of the graph. So the equation of this graph, we knew that a was 10, and now that we know that b is 2/10, so y equals 10 times 2/10 to the x power. And again, it's really great to double check. Notice that this number here is between 0 and 1, and we had a graph of exponential decay. So those do match up. So on 68, I really do suggest you guys try 68 on your own, but I'm going to go ahead and include this video here of how to do 68. So you might want to pause it, read through the problem yourself, and do it on your paper. Okay, I hope you were successful at doing that problem. We're going to use Errol and Sandy's method, basically identify what the y-intercept is. So we know that A equals 5. And then we have to figure out B. The way I like to do this is I like to set it up as a quick small table. My x was 0, my y is 5. That's my y-intercept. And then I had 4 and 1,280. Well, I notice that this increases by 4. So I know it's going to be b to the 4th power is going to equal my new value over my old value. So 1,280 divided by 5 equals 256. So b to the 4th power is 256. So again, I will show you on the calculator. B to the 4th is 256. So I'm going to hit the math button. And I'm going to the 4th power, so I'm going to hit the 5 again. Last time I hit the 5, it wasn't because it was the 5th root. It was just because any root can go on the number 5. We're going to take the 4th root, and we want it of 256. And it turns out that the answer is 4. So b to the 4th is 256. So b equals 4. So my equation is y equals 5 times 4 to the x power. Again, the hardest part of these problems is recognizing what's happening for the x values. If it took 4 turns to get that change in the y, then we're talking about b to the 4th power. If it took, like on the last problem, it took 5 to get there, so we did b to the 5th power. When we did question 66D, we went from 0 to 3, so that was 3, so that's why we used b to the 3rd power was equal to 8. It has to do with what is happening. What's that change in your x? That change in your x is telling you how many times you're using that multiplier. Good luck, and let me know if you have any questions.